Audio Jungle.
Hello everyone, I am Romen Kalutandri. Today I am going to talk two emerging technologies in transportation, the EVs and AVs. Now I am going to tell a small introduction for these technologies, and after that I will tell why I choose these technologies. In recent years, the transportation industry has undergone a significant shift towards the adoption of electric and autonomous vehicles technologies. Electric vehicles are powered by rechargeable batteries and emit fewer greenhouse gases, making them a more environmentally friendly option. Autonomous vehicles, on the other hand, are equipped with advanced sensors and artificial intelligence that allow them to operate without a human driver. Both EVs and AVs are poised to revolutionize the transportation industry, providing safer, more efficient and more sustainable modes of transportation. This introduction will provide a brief overview of these technologies and their potential benefits for society. And next, I decided to work in the transportation industry since it is crucial to modern world and has an impact on everything from the interpersonal relationships to economic growth. The advancement of transportation technology may alter how we move people and things, making it quicker, more efficient, and more ecologically friendly. As a result, this discipline offers several opportunities for innovation and advancement, making it intriguing to study and understand. For the purpose of the communicating transportation technology, I intend to employ a variety of media, including written articles and movies. Through written essays, I will be able to investigate and specific of a variety of technologies and consider their advantages, disadvantages, and potential effects. Video will provide a sensory overload by more interestingly and visually demonstrating how various technologies operate. Finally, interactive recording will let me talk to individual direct while demonstrating how various technologies work and showing them firsthand the potential benefits. In addition to using these mediums, I want to highlight the most interesting and significant advancement in transportation technology. For instance, I might talk about the most current advancement in driverless and electric cars, or the potential for long distance travel to be entirely transformed by Hyperloop technology. By concentrating on these subjects, I hope to provide an accessible and engaging review of the state of transportation technologies today. Additionally, I want to inspire readers to research and participate in this interesting field. The major contents of this showcase project will be as follows: Introduction to EVs and AVs, technologies used in EVs and AVs, benefits and limitations of EVs and AVs, challenges in the adoption of the EVs and AVs, and finally future prospect of EVs and AVs. Introduction to EVs and AVs. Electric vehicles and autonomous vehicles are two of the most significant technological advancements in transportation. EVs have gained immense popularity in recent years due to their environmental benefits and advancement in battery technology. On the other hand, AVs are expected to transform the way we travel, reducing the accidents and increasing efficiency. EVs are powered by electricity stored in a rechargeable batteries and use electric motors instead of internal combustion engines (ICE). These vehicles are considered more environmentally friendly as they emit less carbon dioxide and pollutants compared to traditional vehicles. Moreover, they have the potential to reduce dependence on the foreign oil to improve energy security. EVs have a rich history dating back to the 19th century when electric vehicles were more common than gasoline vehicles. However, advancement in ICE technology and the discovery of oil reserves led to a shift towards gasoline vehicles, and electric vehicles lost their popularity until recent years. AVs are also known as self-driving or driverless cars use advanced sensors, software, and communication systems to navigate and make decisions. They are expected to significantly reduce accidents and fatalities caused by human error while also increasing efficiency and reducing travel time. The development of AVs dates back to the 1920s when the first radio controlled car was invented. However, it was not until the 2000s when the technology began to see significant progress and investment from the major car manufacturers. The current state of development for EVs and AVs is promising, with increasing investment in research and development. The adoption of these technologies is also growing, with more EV charging stations being installed and AVs being tested on public roads. However, there are still many challenges to overcome, such as high cost, limited range, regulatory issues, lack of infrastructure, and consumer acceptance. The benefits of EVs and AVs are many, including reduced emissions, improved fuel efficiency, and enhanced safety. EVs are expected to significantly reduce the carbon footprint of the transportation sector, while AVs have the potential to reduce accidents and fatalities caused by human error. However, these technologies also have their limitations, such as high cost, limited range, and challenges in infrastructure development. The introduction of EVs and AVs represents a significant advancement in transportation technology. While these technologies have a potential to bring significant benefits, there are also challenges to overcome. In the following pages, we will explore the technology used in EVs and AVs, their benefits and limitations, challenges in their adoption, and their future prospects. Technologies used in EVs and AVs. Technology used in electrical vehicles and autonomous vehicles are rapidly advancing, making them more reliable, efficient, and affordable. In this page, we will discuss the various technologies used in EVs and AVs and how they work together to enable these vehicles to cooperate. Battery technology is a key component of EVs. Battery stores energy that powers the electricity motor, providing the vehicle with the necessary power to move. The most common type of battery used in EVs is the lithium battery, which offers a high energy density, long lifespan, and fast charging capabilities. Advances in battery technology and continuously being made with the development of solid-state batteries that offer even higher energy density and faster charging times. Electrical motors are another critical component of EVs. The motor converts the electrical energy from the battery into mechanical energy to propel the vehicle. Compared to the internal combustion engines, electric motors are simpler, more efficient, and require less maintenance. There are two types of electric motors used in EVs: AC motors and DC motors. AC motors are more efficient and are used in high performance EVs, while DC motors are less expensive and are typically used in lower end models. Sensors play a crucial role in AVs by providing the vehicle with 360-degree view of its surroundings. These sensors include cameras, LiDAR radar, and ultrasonic sensors. LiDAR in particular is essential for AVs as it provides high-resolution 3D mapping of the environment, allowing the vehicles to detect obstacles and navigate roads safely. Cameras provide visual data to the AV's computer, while radar and ultrasonic sensors help the vehicle detect the speed and distance of other objects on the road. Software is another critical technology in AVs. The software is responsible for processing the data from the sensors and controlling the vehicle's movements. The software uses the algorithm to interpret the sensors data, making decisions about the vehicle's acceleration, braking, and steering. The software also communicates with their other vehicles and infrastructure to optimize traffic flow, to reduce congestion. All these technologies work together to enable EVs and AVs to operate. The battery powers an electric motor which moves the vehicle. The sensor provides data about the vehicle's surroundings, which the software processes to make decisions about the vehicle's movement. The software then controls the vehicle's acceleration, braking, and steering to ensure the safe and efficient ride. The technology used in EVs and AVs are rapidly advancing, making these vehicles more reliable, efficient, and affordable. Battery technology, electric motors, sensors, and software all work together to enable EVs and AVs operate. As these technologies continue to evolve, we can expect even more exciting advancement in the future of transportation. Benefits and limitations of EVs and AVs. EVs and autonomous vehicles represent significant technologies advancements in transportation. Both EVs and AVs offer numerous benefits, but they also have limitations that need to be addressed for these technologies to become mainstream. In this section, we will discuss the benefits and limitations of EVs and AVs. They are having 5 benefits of EVs. There are environmental benefits: energy efficiency, reduced depends on the foreign oil, quiet operation, low maintenance cost. And limitation of EVs: limited range, high initial cost, limited charging infrastructure, longer charging times. Benefits of AVs: increased safety, improved efficiency, increased accessibility, improved productivity. Limitation of AVs: there are limited reliability, regular recharges. Limitation of AVs: limited reliability, regulatory challenges, high cost, limited infrastructure. EVs and AVs offer numerous benefits, but they also have limitations that need to be addressed for these technologies to become mainstream. EVs offer environmental benefits and energy efficiency, but they also have limited range and require significant investment in charging infrastructure. AVs offer increased safety and efficiency, but they also face regulatory and reliability challenges and require significant investment in infrastructure. As technology continues to develop, we can expect these limitations to be addressed and these technologies to become more accessible and widely adopted in the future. Future prospect of EVs and AVs. The future prospect of electric vehicles and autonomous vehicles are promising with significant potential for the revolutionizing the transportation industry. In this section, we will discuss the future prospects of EVs and AVs. EVs. Decreasing cost. The cost of EVs are expected to continue to decreasing as the technology becomes more widespread and more efficient. The declining cost will make EVs more accessible to consumers and in turn increasing their adoption. Increased range. The range of EVs is expected to increase significantly in the coming years with advances in battery technologies. This will make EVs more practical options for long distance travel. Improve charging infrastructure. The availability of the charging stations is expected to increase in the coming years, making it easier for EV owners to find places to charge their vehicles. Advances in fast charging technology will also help reduce the time it takes to charging an EV. Policy support. Governments around the world are implementing policies to support the adoption of EVs, such as tax incentives and regulations on vehicles' emissions. These policies will help drive the adoption of EVs and encourage manufacturers to invest in EV technology. AVs. Improve safety. AV technology has the potential to significantly improve safety on the roads by reducing the number of accidents caused by human error. As the technology becomes more reliable, AVs will become safer than traditional vehicles. Increased efficiency. AVs have the potential to significantly improve traffic flow and reduce congestion on the roads. This will result in more efficient transportation and reduced travel times. Third one is new business models. The adoption of AVs will likely lead to emergence of new business models such as ride sharing and delivering services. These new models have the potential to revolutionize the transportation industry and create new opportunities for business. Improve accessibility. AVs have the potential to improve accessibility for people who are unable to drive, such as who elderly and those with disabilities. This will increase mobility and independence for these individuals. However, there are also challenges that need to be addressed for these future prospects to be realized. These challenges include particularly issues, cybersecurity concerns, and the need for infrastructure investments. The future prospects of EVs and AVs are promising with significant potential to improve safety, efficiency, and accessibility in the transportation industry. As the technology continues to develop and become more widespread, the benefits of these technologies will become more apparent. However, addressing the challenges facing these technology will require collaboration between policymakers, industry stakeholders, and consumers. Finally, the rise of electric vehicles and autonomous vehicles is set to revolutionize the transportation sector in the significant ways. EVs are already gaining traction as a cleaner and more sustainable alternative to traditional fossil fuel cars, with numerous countries and companies pledging to phase out gasoline-powered vehicles in the coming years. This trend is set to continue with advancement in battery technology and charging infrastructure, making EVs even more practical and accessible to the masses. At the same time, AVs are poised to transform the way we move around with the potential to drastically reduce accidents, improve the traffic flow, and enhance mobility for people who are unable to drive themselves. While fully autonomous cars are still in the testing phase, many AV features are already available in newer vehicles, such as adaptive cruise control, lane keeping assistance, and automatic emergency braking. However, the transition to fully EV and AV future will not be without its challenges. There are still concerns over the range and cost of EVs, as well as the availability and reliability of charging infrastructure. Additionally, questions around safety, reliability, and ethical considerations surrounding AVs will need to be addressed before they become mainstream. Nonetheless, the potential benefits of EVs and AVs are too great to ignore, and it is crucial that governments, automakers, and other stakeholders work together to accelerate the adoption of these technologies while addressing the challenges that come with them. By doing so, we can create a cleaner, safer, and more efficient transportation system that benefits everyone. However, there will be difficulties in making the transition to an entirely EV and AV future. The reliability and accessibility for charging facilities, as well as the cost of range of EVs, continue to be issues before AVs become commonplace. Concern about their safety, legal responsibility, and ethical implication must also be resolved. The potential advantages of EVs and AVs, however, are too large to ignore, and it is essential that governments, manufacturers, and other partners work in order to promote the adoption of these technologies while addressing the problems they present. This will enable us to develop a better, safer, and more effective transportation system that will benefit all road users.